For most of human history, we've looked up at the night sky and seen this beautiful, but mostly unchanging picture. But what if we could actually watch the universe in motion? Well, a brand new revolutionary observatory is about to hit play, and it's poised to completely change how we see the cosmos. It's honestly one of the biggest mysteries in all of science. What is this strange force that's not only pushing our universe apart, but making it expand faster and faster? The Vera C. Rubin Observatory was basically built to go hunt for clues. And then there are questions that hit a little closer to home. How many asteroids are actually out there that we have no idea about? And are any of them a potential threat to us? Well, this new cosmic sentinel is designed to find them. And this really gets to the core of it all. The observatory's mission isn't just about taking pretty pictures. It's about creating a film, a 10-year feature-length movie of literally everything that moves, changes, or explodes in the night sky. So yeah, this idea of a cosmic movie is the absolute heart of this whole project. By taking pictures of the same patch of sky over and over and over again, we get to see the universe not as some static painting, but as a living, breathing, evolving place. The star of this whole show is the Vera C. Rubin Observatory, and it's perched way up high in the Chilean Andes. It's named very fittingly after Vera Rubin, a total trailblazer in astronomy whose work gave us some of the first real, solid evidence for dark matter, which, by the way, is another one of those huge cosmic mysteries this observatory is going to help us unravel.
Okay, so if you're going to make a movie of the entire universe, you need a pretty special camera. And when I say special, I'm talking about the biggest, most powerful digital camera ever built for astronomy, period.
Get this, 3.2 billion pixels. To put that into perspective, your fancy new smartphone might have, 48 million pixels? This camera is on an entirely different planet. So how in the world do you even test a camera this powerful? Well, the engineers took a picture of a head of Romanesco broccoli. The resolution is so insane that you can just keep zooming in, and the details stay perfectly crisp. Now just imagine doing that with a galaxy that's billions of light years away. And it's not just about the incredible detail. It's about the sheer scale. The camera's field of view is just enormous. In one single snapshot, it can capture an area of the sky that would fit 7 full moons. Most other big surveys, they can only capture a tiny piece of one. This is exactly how it's going to map the entire sky so incredibly fast. This whole thing didn't just appear overnight. This has been a monumental effort, literally decades in the making. From just an idea back in the 90s to construction kicking off in the 2010s, that massive camera finally getting finished in 2024, and then seeing first light in 2025. It's just an incredible story of persistence. So with all this incredible power, what exactly is the observatory looking for? Well, its mission is really focused on 4 main scientific quests. Okay, first up, like we said, is digging into the nature of dark energy and dark matter. Second is to take a complete inventory of our own solar system. We're talking finding millions of new asteroids and comets. The third quest is mapping what's called the transient sky, which is a cool way of saying they're going to capture everything that flashes, fades, or explodes, like supernovas. And finally, number 4 is charting our own Milky Way galaxy in just mind-blowing detail. And here's the amazing part. It's already started. Even before its main 10-year survey has officially kicked off, the observatory is already making discoveries that are total game changers. The official first light images that came out in mid-2025 were just, wow, absolutely breathtaking. They showed off the observatory's incredible power, capturing these vibrant stellar nurseries and deep fields just packed with distant galaxies. It was perfect proof that the whole system works beautifully. But the real hint of its potential came during its warm-up phase, when it spotted something truly bizarre. A record-breaking asteroid that was unlike anything we had ever seen before. For starters, this thing is huge. The asteroid, called 2025 MN45, is nearly the size of 8 football fields laid end to end. But here is the part that will blow your mind. This enormous chunk of rock is spinning completely around every 2 minutes. For an object that big to rotate that fast, it's pushing the very limits of what we thought was even physically possible. Scientists are calling it, quote, the fastest spin period known for an asteroid of its size, a record breaker found before the mission had even officially begun. It's just a tantalizing preview of all the incredible discoveries that are still to come. So, what does all this really mean for us, for science? It means we have just thrown open an entirely new window on the universe, and let me tell you, the view is going to be spectacular.
The sheer amount of data is almost impossible to comprehend. Every single night, the observatory is going to generate 20 terabytes of data. By the time its 10-year survey is done, it will have created a catalog with 20 billion galaxies and 40 billion stars. That is a treasure trove for generations of astronomers to dig through.
And maybe the best part of this whole thing is this. All of that data is going to be made public, almost immediately. This completely democratizes access to the cosmos. It's moving beyond just a handful of scientists and allowing anyone, anywhere, with a computer and a curious mind to make the next great discovery right from their own home. The Vera C. Rubin Observatory isn't just an instrument, it's a whole new perspective. It's a new way of seeing time and change play out across the entire cosmos. The window has been thrown wide open. The only question left is, what are we going to see when we look through it?